delta to star and star to delta, certain formulas were given. I think still they are available in the board, on the board, okay. You can see the formulas both in terms of resistance as well as conductance, okay. So we will just discuss, examples, okay, how to solve a network and where do we really require the star delta transformation, and using the star delta transformation, how do we simplify the network, that we will see, okay. And before that, you can also conclude that you have certain relations, okay, you have certain relations here. Note, if RAB is equal to RBC is equal to RCA is equal to, because this is a delta element, right? This is a delta element. Okay, if all these delta elements are having the same value, that is R delta, okay, and RA is equal to, RB is equal to, RC is equal to R star, okay, then we can write that R star is equal to, you can see here, R delta is equal to R star square, R star square, R star square, 3R star square by R star. Finally, you got 3R star. When what is R star? R delta by 3. So therefore, you can write R delta by 3. Or you can write even G star is equal to 3 times G delta. Okay, so please note down this first. Okay, note down this, and then we will discuss problems. Okay, then we discuss the problems. Please note it down. Please quickly note down. Please quickly note down. And then we will see the problems, okay? Note down that. Note down that. Meanwhile, I'm just giving an example. This is an example, okay? Example. Example 1. Determine I total. This is 9 volts, 2 ohm, 2 ohm, 4 ohm, 5 ohm, and 12 ohm. 11 ohm, okay? Let's take it 11 ohm. Let us try to find the current IT. What is IT value? It's an example, okay? Okay, so let us try to find the total current here. What is the total current? Total voltage by total resistance. Yes or no? You calculate what is the resistance across these two terminals. With respect to these two terminals, what is the resistance? How do you find the resistance? Usually using simple series and parallel combination. But look at the network here, how these elements are connected. You see any two elements, you can't relate any of them because they are neither series nor parallel. 11-5, neither series nor parallel. 2-4, 2-2, 4-2, you take anything. Yes or no? Okay. So when all elements are neither series nor parallel, usually, okay, we go for star delta transformation. And you can also observe that there is a bridge. Yes, bridge formed actually. But is it a balanced bridge? No. Look at this, 11/5 is not same as 2/2. It is not a balanced bridge. Remember, when there is a bridge, don't miss that opportunity. Okay, if it is a balanced, just check whether it is balanced or not. your time will be saved. Okay, sometimes the bridge may be balanced. So you have to check whether that bridge is balanced or not. Okay, so this is an unbalanced bridge, then you don't have any option other than the started transformation. Okay, to find this total resistance across the input terminals or across the source terminals, taking this is A, this is B, you need to find RAB, right? Now, let us simplify. Let us try to identify first of all what is the star, what is the delta here. What is the star? Actually, three elements with a common node is a star. Three elements with a common node is a star. Yes, these three are forming star. There is no problem at all. Only three elements, not four elements, only three elements with a common node. Those three elements are said to be in star. And three elements in a common loop or in a particular loop, let us say, then it is forming a delta. These three are in delta. These three are in delta. Yes or no? Okay. So you can select either delta to star or star to delta. Doesn't matter. Okay. You will get an answer. But sometimes you can also judge which is best in the given situation. In the given situation, which transformation can be chosen. Sometimes it will be easy based on the numbers given. For example, you see 2, 2, 4. That means there are two elements are having the same values. So your computation time will be reduced. Yes or no? Okay. When you have three elements same, better you choose that particular transformation. Okay. You can choose that particular combination to transform to its counterpart. Okay. So look at this now. I can choose this. It does not mean that you should not choose this. You can choose, not a problem. But since the 2 and 2 are same, okay, because there are two elements, out of three elements, the two elements look same, therefore I can go for it. Because if I calculate one element, the other element is also calculated. I don't need to put the effort to calculate that particular value. Okay. So how you form a star now? Forming a star is something like this, between these elements, between these elements, A, B, C. Instead of writing A, B, C, I remember now that the formula is already, okay, and I construct, there should be one element here, there should be one element here, there should be one element here. Yes or no? Okay. Now if I call this A, B, C, this is RA, this is RB, this is RC, right? And you also remember what is RA. RA is nothing but, okay, RA is nothing but RAB, RAC, RAB into RCA by RAB plus RBC plus RCA. But I remember that this element will be adjacent elements product by sum of all the elements. Okay. Similarly, this one also adjacent element. So what is this element value? 2 into 2 by 2 plus 2 plus 4. Okay. What is denominator actually here? 8. Remember this denominator in delta to star transformation, the denominator is same. Okay. So it is 1 by 2 ohm. But remember this denominator 4 into 2 by 4 into 2 by, okay, 8. That is 1 ohm. If this is 1, this is also 1 because this is also 4 into 2 by, yes or no? Okay, this is also 4 into 2 by 8. This is also 1 ohm. That's why I told you, you get the same value. There is no need to put efforts. Directly you can write 1 ohm here. Okay. Now, let us reconstruct the network. What is that network you are going to see? See this? Yes or no? I'm just disconnecting these delta elements, throwing those delta elements off and replace it by its equivalent star. This is what the resulting you are going to get, right? Now, you see, this is plus minus 9 volts. What is this value here? 5 ohm and this is 1 ohm. 1 ohm, this is 11 ohm. This is half a ohm, right? Now tell me, how these two are connected? Series. How these two are? Series, then parallel, then series. So therefore, 11 plus 1, this is 11 plus 1, 12 ohm. This is 5 plus 1, 6 ohm. And 6 and 12 are in parallel, plus half, okay. Now, what do you get here? The R total or R input, let us say, this is 4 plus half, this is 4.5 ohm. But already you have the voltage, right? You can find the current. I total is nothing but total voltage by total resistance 4.5 ohm. This is 2 ampere. I think all of you understand this. Note it down. Note it down. Meanwhile, I just give you another problem, okay? Another example, okay? Second example. Note down that all of you, the solution. Meanwhile, I just give you another problem. So star delta transformation you apply when all elements are neither series nor parallel. When all elements are connected, neither series nor parallel, you can go for star delta transformation. Find RAB. Note this problem, solution, and then note down that problem as well. Find RAB. Find RAB. If you find there are no series and parallel, all neither series nor parallel case, generally we go for star delta transformation, right? Wherever the reduction is not possible using series and parallel, there we generally prefer what? Star delta transformation. Look at this. This network, if you see, I think immediately your focus must be on these two elements, I think. How these two elements are connected here. They are in series. Yes or no? Okay. So if you take them in series, okay, then rest, after that, after series combination, replace these particular two elements by one element, then you see the resulting network. All elements are neither series nor parallel. Yes or no? So therefore, let me draw it again. Let me draw it again. It's something like this. Now what is this actually here? 6 ohm. Because this is 4 plus 2, 6 ohm, right? So the 6 ohm I'm placing here. And this is already 6 ohm. This is also 6 ohm. This is 18 ohm and 9 ohm and this is 10 ohm. AB. Clear? Now you see, all these elements are neither series nor parallel and they're also forming a bridge. I think you can closely observe. 6 by 9 is not same as 6 by 18. It is an unbalanced bridge. Bridge, but it is unbalanced. Under unbalanced condition, you are supposed to solve the network only using star delta transformation. Now, this is forming a delta. This is also forming a delta. These three are forming star. These three are forming star. Okay. Yes or no? But which one is to be chosen? That is an important point here. Which one is supposed to be chosen here? I told you in the selection, you have a right to choose any three elements, either star or delta. It doesn't matter. But I generally suggest that wherever you have same elements, suppose if all elements are same, better you choose that because the calculation part will become easy. Okay? There is no need to work on the calculator. You see here now, these three are looking same. Therefore, can I transform them into delta? Because already star is existing here. Then you can go for what? Delta. Okay. Now, R star is equal to R delta by 3. Yes or no? But already you have a star element. Now you need to find R delta. That is R delta is equal to 3 times R star. That is 18 ohm. Okay. So this is 18 ohm. This is 18 ohm. Yes or no? See how simple it is. You can save time if you choose this. Otherwise, you have to calculate. You don't worry, you get the answer, but you have to calculate and it may take a few seconds or sometimes a minute also. Okay. Now, let us replace. Let us cut down these star elements. Cut down star elements means only just like this. Don't touch the remaining part. Don't touch this, don't touch that. Only remove the elements. That's it. Remove the star elements. That's it. So you can throw off that star connection and the rest of the part, how it looks like, tell me. Now it looks like something like this. Okay. Okay. See this. What is this? 18 ohm. 18 ohm, 18 ohm, 9 ohm, 18 ohm, 10 ohm. This is what actually you're going to do. Now, see this, how these two elements are connected. 18 and 18 are parallel. How these two are connected? 9 and 18 are parallel, yes or no? And then they are in series. That result is parallel to 18, yes or no? So now, what is actually 18 parallel 18? 18 parallel 18 is what? 9 ohm. 9 parallel 18 is what? 9 into 18 by 9 plus 18 is, I think you're going to get 6 ohm. Yes or no? Okay. Now this 9 and 6 are connected in series. That result is parallel to what? 18. And that result is in series with what? 10. Okay. So therefore you can see the total REB can be written something like this. 9 plus 6 parallel with 18 plus what? 10. This is 15. 15 into 18 by 15 plus 18 plus 10. 15 8 ja 120. 15 1 ja 15 plus 12 270. This total is 33 plus 10. Finally 33 330 plus 270 600 by 33. You get 200 by 3 times, right? 11 ohm. This is what your answer. Okay. I think all of you understand how we simplify the network using the star delta transformation. Please note down. Third problem. Determine the value of V. Determine the value of V. Determine the value of V in the given circuit. Okay. Determine the value of V in the given circuit. Now tell me, how do you solve it? Look at this network. Total voltage you want. Total voltage is nothing but total current into total resistance. Yes, an Ohm's law, just we are applying. V is equal to I into R. I is available and we want to find the R. Now R with respect to these two terminals, treating these two terminals as AB terminals. Now let's find RAB. We are good at finding equivalent resistance now because we know started the transformation, right? So why we go for started transformation for this particular network? It's very clear that these two neither series nor parallel. You take any two elements, neither series nor parallel. Now let's choose properly the delta or star to transform into its counterpart. Shall we select the star or delta here? Shall we select this star into delta? Or shall we select this delta into star, this delta into star, this delta? No, I think it's not forming in delta because the reason this consists of what? 1, 2, 3, 4 elements. 4 elements with a common loop is not a delta. We do not know what exactly it is. Okay. but 3 elements with a common delta. Delta, delta, star, yes or no? These 3 are forming star, no problem at all. Okay, but I prefer this. I think all of you understand why I'm choosing this, because this delta is having same values. The calculation will become a little simple. Okay, so let me put a star here for these 2 elements, one for these 2 common element. That's it. Okay, so R star is nothing but what? R delta by 3. You already have a delta, but you need to find star. Therefore, it is 2. So this is 2, this is 2, this is 2. That's it. Understand? Okay. Now after that, let us cut down the delta elements. You just cut down this delta element. This. Throw the delta elements off. Okay. Throw them out. Okay. Now you are left with what? This 2 ohm is connected to 1. This 2 ohm is connected to 8. This 2 ohm is connected here at this node. Now this is the point. If I say this is A, now A is something here. Look at this. A is something here. Okay, I'm just modifying it. Something like this. Look at this. This is A. Now you have, this is 2 and 8. And you have here. Yes or no? Okay. That's it. This is 2 ohm, 2 ohm. I have just, shifted this node to this position. Then this 2 will be already in series with this. This 2 is connecting here. This 2 is connecting here, this 8 ohm, right? So finally you got this, right? Now look at this. This is 4, this is 6 already. What about this? This is 10 ohm. Now it's forming a bridge. Yes or no? And this is 1 ohm already. What is this again? 2 plus 1, this is 3 ohm. This is forming a bridge. Yes or no? Now you check whether it is a balanced bridge or not. If it is balanced, you don't need to go for what started a transformation. Yes or no? Look at this. This is 3, 6, 2, 4. I think 3 by 6 is equal to 2 by 4. It is a balanced Wheatstone bridge. Whenever you find a bridge, first you check whether it is a balanced or not. Now the current flowing through 10 ohm will become what? 0. Current 0 refers to what? Open circuit. You can apply the balance condition, either current 0 condition or voltage 0 condition. For instance, I'm applying current 0 condition. Now what could be the total resistance here? Okay, the current flowing through that particular path is 0. Therefore, 3 and 2 are in series, 6 and 4 are in series, and the resultant is in parallel, and 5 parallel 10, I think you get 10 by 3 ohm. But you are asked to find the total voltage V. This is what given 3 ampere. Now V is equal to 10 by 3 resistance, right? Into 3, this is 10 volts. That's it. You understand, all of you? So this is how you can solve. Please note down quickly. Note down. Please quickly note down the solution. Then we will move on to the next topic. These are the 3 examples. Okay. There are so many we can solve using the same logic. Okay. But one must remember, okay, how the formulas, which are very important. The formulas are very, very important. Start to delta and delta to start transformation. Better you remember both in terms of resistance and conductance, because the same thing is useful to you even in case of inductors and capacitors. Right? I am not erasing that part. See, we started. I think all of you finished this. Okay. If you finish, then let's move on to another important topic. Do not write anything. I'm just explaining you a simple concept here. See, our objective is what? In the first class itself, I explained you that we are dealing with what? Network theory, right? Network theory, we divide into two parts: network analysis and network synthesis. Yes or no? Network analysis means network is given, input is given, you are expected to find the output. The output might be current or voltage. Of course, even if you get the current or voltage, then obviously you know the power. Okay. Synthesis is something different. So let us keep the synthesis for a moment aside. Our main concern is now how to analyze a given network. People call it how to solve a network. Okay, but the right word is what? How to analyze a network. Analysis point of view, whenever you see a particular network, okay, randomly you pick any network from any textbook, from any, exam. Usually the networks can be divided broadly into just two categories: single source networks, multi-source networks. Yes or no? How the network looks like, tell me. Either it is a single source or else it is a multi-source. Usually the single source networks can be solved using simple methods like current division and voltage division methods. Multi-source networks, usually they can be solved using node analysis and mesh analysis. So simple, it's very simple that any network, the networks are of two types. Broadly, with respect to the number of sources I'm dividing, again the networks can be divided into AC network, DC network. That's a different story. Okay, steady state, a transient, that is a different story. I'm just dividing these networks into two categories based on the number of sources that they present. Okay, first the networks are divided into, okay, single source, single energy source networks, multi-energy source networks. So once you look at that network, you must be in a position to judge which method is very important to apply. Yes or no? So these single energy source networks can be solved using both current division or voltage division. Okay, the multi-source networks are solved usually by mesh analysis or node analysis. Okay, simple, that anybody can easily understand. If you really remember like this, okay, then you can easily solve the problems. Okay, so networks are divided into two categories. Let me write clearly the networks, classification of networks. Okay, so networks are divided. Networks are of two types: single energy source networks, multi-energy source networks. Single energy source networks are usually solved by current division and voltage division. Multi-energy source networks are divided, can be solved using what? Mesh analysis and node analysis. Please note down that quickly. And now we will choose in this particular session the single energy source. Then we will switch over to what? Multi-energy source networks. Okay? Please quickly note down that point. Networks are divided into two categories. So when you look at the network or when you come across a network, immediately you must judge whether it falls under the first category or second category. That's it. Whether you want to go for current division or voltage division or else node analysis or mesh analysis. Okay. So now let's put the heading current division or voltage division methods. This is an important topic. Voltage division methods. Current division or voltage division methods. Okay. First we start with current division method. Okay. First we start with current division method. To make you understand this current division method, let's take the problem directly. Okay. So please open your classroom workbook. In that you have one problem. Problem number. For current division method, I am taking a problem here. The question number 20. The question number 20. Classroom workbook. Okay. Classroom workbook. Question number 20. Please take that problem. I'm just noting down here. The same network we will solve using both current division and voltage division methods. Okay. Just to get a clarity and command over the network, okay, we will solve step-by-step procedure, using step-by-step procedure systematically. We will solve systematically, okay. Just to avoid the confusions, you might be having some confusions when you solved the networks in your first year standard or first semester or second semester or first year or, okay. So that is why, because most of the people are generally confused in networks solving, okay. They solve the given network, but when new network is given, again they have a problem. There are many students are like that. So keeping in mind all sort of students, all category of students, I'm just explaining in detail, okay. And look at this step-by-step approach. Look at this step-by-step approach. What is this method actually? Current division method, right? Current division, it says that, find the total current, then divide the current. Find the total current, then divide the current. What is the total current actually here? The total current can be calculated here easily. What is the total current actually here? Total voltage by total resistance. What is the total resistance? Come in the opposite direction, 1 and 4. 1 and 4 are in series. That is how much? 5. 5 and 20 parallel. That is 4. 4 plus 2, 6. That is series, right? 6. 6 and 12 parallel. 6 into 12 by 6 plus 12. 4. 4 and 6 series. 4 plus 6, 10. So total voltage by total resistance is how much? Okay. Total resistance is how much? 10 ohm. This is giving you 3 amperes. Is it clear, all of you? Now we need to divide this current among all the elements. Okay. How do you divide the current generally? Okay. When does the current division happens? Tell me, all of you. Okay. The current division happens when, look at this, these two are in series. The current delivered by the source is same as current through 6 ohm or not? Yes. Now current is flowing up to this particular node. Okay. There is no division at all. But here you find division because there are two different paths. The paths are splitting. That node, from that node, the paths are splitting. Therefore, now you find the current here and here. Now let's find the current here and here. Okay. You need to apply the current division rule. To find the current through one path, when the division is taking place, you are supposed to apply what? Current division rule. But current division rule is applied to a parallel elements or series elements, or neither series nor parallel. Absolutely only for parallel elements. See how these 12 and 2 are connected? Are they in parallel? No, they are not in parallel. These two are neither series nor parallel. Therefore, the current division rule is not applicable to this 12 and 2 because these two are neither series nor parallel. For that reason, we temporarily simplify the network up to these 2 points. Just simplify this entire part of the network, and that network is replaced by a single equivalent element here. Now that element and this element will be in parallel. Then you can apply the division rule. Yes or no? So let me apply temporarily. I'm just, temporarily, I'm just reducing the network something like this. What is this value? 6, and this is 12 ohm. And what is this value? Is also 6 ohm. So what is the current actually flowing here? The current flowing here is of 3 ampere, right? Then let me actually find the current through 12 ohm. What is current through 12 ohm? Opposite resistance 6 by 6 plus 12 into 3. 18 by 18, 1 ampere is flowing. So the current flowing here is 1 ampere. Yes or no? What is the remaining current flowing here? To satisfy KCL, 3 amperes is flowing here, 1 ampere. The remaining current must flow. There is no need to apply the formula again. Directly apply KCL here. 3 minus 1, that will give you the remaining current 2 amperes. Now this is the temporary arrangement. You got now here 2 amperes. Now go back to the original circuit. You already understood that, okay? You already understood that the current flowing in this particular point, at this point means this point, right? So therefore this is 1 ampere and this is already 3 amperes. Then obviously here it is 2 amperes. Now this 2 amperes is actually flowing up to this point, the same current. Now it gets divided. Yes or no? Now it finds 2 paths. One path is having the resistance 20. The other path, total this entire portion you are supposed to take. You can't divide for 20 and 1 because 20 and 1, they are neither series nor parallel. 20 and 5, what is this? 5 ohm, they are in parallel. 5 and 20 are in parallel. Now let us divide. Directly I am working out here. This is actually 2 amperes. Here also 2 amperes. Now the current here, 20 ohm, current through 20 ohm is opposite, that is 5 by 5 plus 20 into 2. That means 10 by 25. That means 0.4 amperes. This is 0.4 amperes. If this is 0.4 amperes, then what is it going to be? The remaining current flows what? The remaining current flows through current through 5 ohm is same as current through 1 ohm is same as current through 4 ohm because they are in series. Current through 1, current through 4, current through 5 all are same. That is 2 minus 0.4, that is 1.6 ampere. Now therefore this is 1.6 ampere. You see I got current through each and every element here. Okay. Now if I know the current, I can find the voltage. If I know the current, I can also find the power. For example, if I just find what is the power of this particular element, if you see, okay, voltage across 2 ohm I am taking. Voltage across 2 ohm is current through 2 ohm into 2. What is current through actually 2 ohm? 2 into 2 here, that is a 4 volts. What is the power of 2 ohm? Power of 2 ohm is current through 2 ohm square into 2. What is current through 2 ohm here? 2 amperes. So 2 square into 2, that is going to be 8 watt. I hope you understand. Similar way, you can calculate for each and every element the voltage as well as power. Once you know current, you can find the voltage, you can find the power. Please note down. The same classroom workbook, question number 20, we are in. Now we are using the voltage division method for the same problem. For voltage division, find the total voltage, then divide the voltage. For current division, find the total current, then divide the current. Yes or no? So therefore, let us see now. But already the total voltage is available. Yes or no? Already the total voltage is available. There is no need to find the total voltage once again. But we need to divide this voltage. But voltage divide, if you want to divide the voltage, you generally consult voltage division rule. But voltage division rule is applicable to what? Voltage division rule is applicable to what? Only when the elements are connected in series. Yes or no? Only when the elements are connected in series, you apply the voltage division rule. Now let us see here. But this voltage cannot be divided for these two elements, because how these 6 and 12 are connected? They are neither series nor parallel. Therefore, I want two series elements. I need to create two series elements. Temporarily, I am reducing the network up to this particular portion. Okay. Then 1 plus 4, 5, 5 parallel 24, 4 plus 2, 6, 6 parallel 12, 4. Now 6 and 4 are in series. Yes or no? Temporarily, I am reducing the network something like this. This is 30 volt. Okay, this is 6 ohm and this is 4 ohm. What is the voltage across 6 ohm? 6 by 6 plus 4 into 30. Now what do you get here? Now 18 volt. What is the remaining voltage? 30 minus 18, this is 12 volts. So this is now the division rule. When you apply plus minus, remember the division plus minus, then plus minus and plus minus. How you got these polarities? Without these polarities, you cannot satisfy the KVL, right? So therefore, the polarities are supposed to be placed such a way that the KVL is satisfied. That is 18 volts and this is 12 volts. Now go back to the original network. Here you found 18 volts and here you got, what is this? 12 volts. Understand all of you, okay? Now, these 12 volts are supposed to be divided again further. But for that you require two series elements. One series element is readily available here, but another series element, you need to reduce the network temporarily once again here. I'm just going to reduce the network, something like this. Now plus minus 12, okay, this is what, 2 ohm. Again you got 4 ohm, okay, up to these 2 points you got 4 ohm, you see. Now voltage across 2 ohm is 2 by 2 plus 4 into 12. What do you get here? 4 volts. What is the remaining voltage to satisfy KVL in this? This is plus minus 4 volts. Then obviously what is the remaining voltage here? 12 minus 4. This is going to be what? 8 volts. So you got 8 volts here. You understand all of you? Now go back to the original network. This is 4 volts. And what about this? 8 volts. Now these 8 volts must be divided further. Here itself, I don't want to actually reduce it once again because already two series elements are available. The voltage between these 2 points is 8 volts. Therefore, voltage across 1 ohm is 1 by 1 plus 4 into 8. I think you get 1.6 volts. And the remaining voltage is now 8 minus 1.6. This is 6.4 volts. So this is now 1.6 volts and this is now 6.4 volts. I think you understand. You can easily calculate like this, okay? Using, I think 1 more kilometer you can extend the similar network if you have even to that particular distance, okay? So this is how you can calculate. And finally, the current through 2 ohm can be calculated. Voltage across 2 ohm by 2. What is the voltage across 2 ohm? 4 by 2. This is 2 ampere. I think you got the same answer in the previous case. Power of 2 ohm is nothing but voltage across 2 ohm square by 2. That is, voltage across 2 ohm is 4 square by 2. I think you got 8 watt. I think you got the same answer as in the previous case. Okay. So note down this.